One, two, 1, 2. Mic check. 1, 2, 1, 2. Okay, okay, okay. Good day, everyone. Um, you know, sometimes these things of testing the sound, I have to check, okay, and then I go to the other side to listen and see if it's fine. That's the beauty of working for all departments. But yeah, it's fine. So yeah, man, this is the question that we'll be doing, or rather, this is the question that I want us to look at. Let me just put it up there. I don't know if I have, but if you zoom in, you'll see the question proper. I want in 10. I'm not gonna have time to do the whole question. For now, like I say, I'm just testing the sound again for the last time. So I'm gonna do question 10.1. I'll do question 10.1.1, and then I'll do question 10.1.2. From then we'll continue with the rest of the question tomorrow. I think I may try to do the question round about say between 8 and 9 o'clock. I'll try to give myself time, but then this is the question we'll be doing. But the reason why I want to do 2.2 and 2.3 later on is because tomorrow during the day, I may put a video out for the introduction of this part. The part you may call it conditional probability. Okay, sharp. Oh, let me look at the camera. So the part you may call it some, well, not some, but then part of it is conditional probabilities, part of it is probabilities of compound events or compounding events. But then the word compound, it goes way big because we have compound interest in financial mathematics. We have compound in Nigeria, where it probably represent a house of some sort or a neighborhood. But then compound, we'll see what it means when we get to that part. But for now, without stressing, let's go straight to the question. So it's question 10.1. It reads a group of people. You know what? Let me read it from my phone because from here is a bit too far from me. So I'll do this so we can read the question together. And then I'll read it from here. Maybe it'll be more visible than it is, but then I may share a slide for you to can see it on your side also. So here we go. Probably this is better. Oh, it's fine. I can just go straight and read it out for everyone like this. A group of people participated in a trial to test a new headache pill. So, from these people who participated, 50% of the participants received the headache pill, and then 50% of the participants received a sugar pill. 2 of 5 or 2/5 of the group receiving the headache pill were not cured. So 2/5 of the ones that received the headache pill, they were not cured. And then 3 of 10, meaning 3 out of 10, that is like 30% of the group receiving the pill were cured. So now question 10.1.1, they want you to represent the given information on a tree diagram. And you have to indicate your diagram, indicate on your diagram the probability associated with each branch as well as the outcomes. Right. So without even wasting time, this is the case here. Um, well, like I say, obviously there are videos that I've already made that I explain the introduction of probability, and this section is just extracted from the past question paper. So this is mainly what you face in papers when you're writing the final or your assignments or whatever. But then I'm not gonna go into the explanation of what is what from the start. And man, I hope my camera is still fine. Let me just quickly check that angle there. Let me see if I'm still okay. I'm still okay. I was just doing something else here. I was just making sure if I'm still, because like you know what, like I say, the technical errors, they can be a bit challenging if you face them by yourself. So yeah, man. Back to the question. So we're here. We're given that information there, and the topic is probability. And well, algebra, calculus is still challenging by itself, but then there should be some type of like a breaking yarn where you get to like take a breath and feel like, okay, Shap, you know what? Here, I'm collecting all the marks. That's how I feel in a perfect world. And to me, a perfect world is a world where my expectations, they become 100% fully fulfilled. And that case would be like, I expect like statistics to be like at least merely an easier topic as compared to every other thing that students are facing all the time. A lot now. It's time to solve some problems. So they want us to draw a a diagram, a tree diagram for that case there. So let's put it on the board and see where does it put us. But then otherwise, so you have two cases here. Let's break it down. We have two cases. We have two participants. They got two types of so they got two types of drugs. So we have event A. Event A in this case would be, you know what? I enjoy colors. I enjoy using colors so it can make sense all in all. Let's use, because the blue pill, we have a blue pill and a red pill, right? Let me just confirm the we have a blue pill and a red pill. Last time I checked. No, man. You see, the problem here, it has nothing to do with the figures. The problem here, it has nothing to do with the figures. You know what? If you're watching this video by the time it's fully recorded, you can just skip the whole part where I'm explaining and just go straight to I'm solving the question, because uh, this is live, and at the moment I don't have any comments or anything, so I feel like I'm free to can explain further and further and further. But then if you happen to join us and you have any comment or you do want to say something, you can just from whichever platform, or rather from whichever social media platform that you're consuming this from, you can there, and then I can see because I feel like I actually made this recording a bit late because most people are sleeping at this time. But then some of this recording are being saved. And it's like I said, I'm not gonna do the whole question. It's just like the introduction, this part. So let's use blue for the headache pill for the first event. So I'm gonna use blue for the headache pill. Let me just go there to show the. So I'm gonna use blue pill for the first event. Event A is the blue pill. And then event B is the red pill. And what is the red pill for this case? From the people who took the pills is the headache pill and the sugar pill. So yeah, headache. I can okay just for our special student. I'm joking. There's no such a thing. For myself to remember, I'm gonna put an invisible H there for the headache pill, and an invisible S there for a sugar pill. So it's two pills, right? Sharp. So pill. Let me just go back to my information because now I'm being overexcited. Uh, nah, this one will take us a bit far. I think if I can explain like this, I'll lose myself because I'm just trying to make the whole thing. Let me state it like this. So we have two cases. Um, it's either from the head. Okay, so I'm it's a tree. It's a tree diagram. I don't have to complicate the whole thing. So there are two pills given. Let me do this. Let me explain like this again. Like sometimes I feel like I'm showing my face, because I'm showing where I'm writing. Sometimes, but yeah, let me just. So before I draw the actual diagram 2.1.1, we have two cases. Depends. They are given a headache pill and a sugar pill, right? And then there's part where they're saying something about the 50% of what. Let's see what the 50% of what says. Let me go back because I want us to get the whole thing clear. 50% of participants receive the headache pill, and then 50% receives the sugar pill. Now that one is clear. 50 of the whole participant, 50% receives a sugar pill, 50% receives a headache pill. And then from that 50%, they are saying something like 2/5 of the group receiving the headache pill were not cured. Now, probabilities, we have the so-called complement. If the probability of something to occur is this much, the probability of something not to occur will be 1 minus whatever the event may be, because the total probability is 1. I've said that in a video where I'm introducing the probabilities. So this is how it works on paper. If the probability of A, okay, automatically the sum of all probabilities must be equals to 1. If you add all your probabilities, you must always get 1. So this rule goes further and say probability of A, if you have two cases in this, probability of B must always be equals to 1. So meaning probability of 1 plus probability of 2 plus probability of 3 up to probability of n must always be equals to 1. So whenever you add all the probabilities, you must always get 1, which is 100% sharp. What does that mean? That means that now, if you have the probability of A being equals to, say, 2 over, I mean, let me just see. Yes, 2 over 5. If you have the probability of A being 2 over 5, for this case where we are looking at the case, where um, the people who had the blue pill, they were not healed. 2 of 5, they were not healed. It means that the ones that were healed, which is the probability of B, would be, to make that one, would be 3 over 5. Do I get that? I calculated it. I just didn't show my calculation, but I just know that the probability of A plus the probability of B must give me 1, right? And then the probability of A was 2 over 5 plus the probability of B is equals to 1. So I didn't know the probability of B then. So to get the probability of B, I took the probability of A to the other side because I know that the sum of the probabilities must give me 1. So I said 1 minus 2 over 5. To get this, man, there's a video again that I make for children where you add and subtract fractions if you don't understand, but you can punch it in a calculator or whatsoever. But then just because I'm a good person, you can just say any number is over 1. 1 divided by 5, um I mean 5 divided by 1, I mean, like, you just ask yourself how many times does 1 goes into 5, which is 5 divided by 1. It's 5 times. 5 times 1 is 5. So it's going to be 5 minus how many times that 5 goes into 5. It goes once, which is 5 divided by 5. But then you multiply it by the numerator, which is going to be minus 2 over 5. Then there's going to be 3 over 5. Hence the probability of B is 3 over 5. So I don't want you to get wrong whenever I fill up my tree diagram. You see. So it's going to be at a point whenever it's time to fill up my body diagram, remember that the total probability, whether it's 2 events, whether it's 3 events, whether it's 100 events, whether it's 1,000 events, the total probability summation, if you add all the probabilities, you must always get 1. The moment it gives you anything more than 1 in a branch, you're not doing the right thing. So we're sticking to 1. Now, a branch and see how does the whole thing fits in. So I would say, picture it like this. For the first one, people that receive headache pills and sugar pills. What is the value of the sugar pills? The probability to present it there. It was 50%. 50% is 1 over 2. Everybody knows, any mathematics students, any student who's studying mathematics should understand that 50% is that. But then now from the headache, we have some that were cured and then some that were not cured. Also on the sugar, we have some that were cured, we have some that were not cured. You understand? So from this, what do we know? They gave us an extra information. Let me just open it again on my side. They say 2 over 3 of the group receiving the headache pill were not cured. So from the ones that are not cured, we have 2 over 5, sorry. So 2 of 5 of the people that are not cured. Let me use a different color just for visibility there. So over 5. 2 over 5 were not cured. And also 3 over 10 of the group receiving the sugar pill were cured. So the ones that were receiving a sugar pill, they were cured. The ones that they were cured pill is 3 over 10. Let me just write it under the branch so it can be bigger. 3 over 10. So 3 over 10 cured from receiving the sugar. If you wanna know the ones that were not cured, you just say 1 minus 3 over 10. And I'm telling you now, whether you believe me or not, 1 minus 3 over 10 is 7 over 10. So 7 over 10 were not cured. And then from the sugar, 7 over 10 were not cured. Since we know that 3 over 10 were cured. Same applies here. We just calculated it now. If 2 over 5 from the participant that received a headache pill, they were not cured, we know that the ones that were cured is obviously 3 over 5. Because when we add this and this, we should get the total probability of 1. Also, when we add this and this, we should add the total probability of 1. Extending on the branch. Also, when we add half and a half, we'll get the total probability of 1. So this is 10.1.1. This is how you show the tree diagram of the probabilities that were stated there. Now let's go to the next question. Man. The next question, it's just 2 marks. I'll try to squeeze the next question right here. I'm just going to say 10.1.2 there. Because it's straightforward. They want you to calculate the probability of, let me just go to the question so we can read it together. Also, so they want you to calculate the probability of, okay, let me just read the question out loud. Because if I convert it in my head, it becomes a challenge. Determine the probability that a person chosen at random from the group will not be cured. So they just want to know what is the probability of everyone not being cured, right? We'll look at it like this from this one, because like I say, we can just take it from here and then just go ahead and answer it directly. So here we have 10.1.2, right? We already know not cured is blue, but half of not cured and also half of not cured. So the ones that are not cured from the headaches, the ones that from the half of the participant, the ones that are not cured from the headache pill, it's 2 over 5. And the ones that are not cured from the sugar pill is 7 over 5. So this is how you calculate. But I don't have space there. I was avoiding to erase. So the probability of not cured, yeah, I can't not erase. But just remember, okay, let me just do this. We know that healed is half people, and then healed and not cured, we know that is 2 over 5. And we know that sugar, it's also half the population or the participant. And we also know that sugar and not cured is 7 over 10. Those are the chances we have. Now, let's put it into calculations. Now you've seen the vector. Look at me. Listen to me saying vector diagram. You have seen the tree diagram. The nice thing about technology is if you don't understand properly, you can just pause, because clearly the video would be saved under the recorded videos. So to get the probability of not cured, it's going to be the probability of headache pill multiplied by the ones that were not cured, and then you add that to the probability of sugar pills multiplied by the ones that were not cured. So headache not cured, sugar not cured. HN. Headache not cured, sugar not cured. But then headache is 50% multiplied by the ones that were not cured, plus sugar 50% multiplied by the ones that are not queued. So this is how we calculate the probability. It's going to be 1 over 2 for this value here, multiplied by 2 over 3. 2 over 5, plus half multiplied by 7 over 10. So like I say, half, which is the headache pill, multiplied by the ones that were not queued from the headache pill. Then you add the sugar pill multiplied by the ones that were not queued from the sugar pill. And this is the answer that we get. If I punch this on a calculator, okay, I found my calculator now. If I punch this on the calculator, I get 0.55. 0.55, if I write it properly, it's going to be the same as 11 over 20. So the probability of everyone being not queued according to this, which is now is 10.1.2, that is 11 over 20. I wish at this point, I wish I could tell more regarding this, but then, man, it's late, and I can see no one is online in all different platforms. I was just talking to myself, and I believe whenever you get to see this recording, it will be helpful. Otherwise, I still keep on checking my comments, even if it's later on. Just excuse me. If you have any question like here, you can just which regardless from whichever platform you're watching this from, you can just send us your comment. Otherwise, alternatively, you can just send us a WhatsApp message even to 081 465 2676 if you need some assistance further regarding this. Even furthermore, the nice thing is because it's exam now, you can even send us any question you may have in mathematics, physics, statistics, economics, accounting. Even if it's not me who's helping, we have a lot of people who may assist in the name of preparing for your exams so to get better marks and stuff like that. Other than that, man, I can't answer the whole questions for now. We only did 10.1, and that's when we focused on 10.1.1 and 10.1.2. On the next event, which is probably going to be tomorrow, we'll finish the question paper so we can proceed with other work. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. All we need is just for you guys to subscribe on our YouTube channel so we can be motivated to keep on pushing the work. But for now, please just subscribe, press the reminder button. So next time we make such videos, because like we just go live randomly every now and then you'll be reminded when there's a next video upcoming, even if we schedule some of the videos. Till we meet again. I'm out.